Today in this video we are discussing how to find capacity of reservoir. Before going into the methods of to find the capacity of reservoir, let's say what is a reservoir. Reservoir is an important hydraulic structure, or we can say it's an artificial lake in order to store water for different purposes. So which all are the purpose a reservoir is constructed for? The primary purpose is, as we already know, it's the storage and control of water for irrigation, and also used to storage and diversion of water for domestic purposes and industrial uses, development of hydroelectric power, increasing water depth for navigation, storage space for flood control, debris control, preservation and cultivation of useful aquatic life and recreation. Then coming to the important topic of the day, that is the capacity to method to finding the capacity of reservoir. So we already seen some purposes of reservoir. In order to meet this purpose, we must design a reservoir. So designing a reservoir basically means finding the capacity of the reservoir. So in order to find the capacity of reservoir, it is mainly depends upon two things, that is inflow available and the demand. Whenever the inflow available is greater than the demand, then there is no need to construct a reservoir. Only in such conditions where demand is more than the inflow rate, then in such a condition we need to construct a reservoir and we need to finding the capacity of a reservoir. Okay, just think that if we have enough inflow than the demand, then there is no need to store water, right? So whenever there is a demand more than inflow, then we need to construct a reservoir. So in order to finding the capacity of reservoir, basically we have two methods, that is first is graphical method and second one is analytical method. Among these, graphical method is most commonly used and important, which is also mentioned in our syllabus. So we are discussing with the graphical method only, that is using mass curves. I think mass curve we already discussed in module 1, already discussed. So if you are not remembering, no need to worry. I will give a summary what is a mass inflow curve is. Mass inflow curve is nothing but it's a curve between the time in x-axis and cumulative inflow in y-axis. Okay. So what is the meaning of cumulative? Cumulative means nothing but it's a summation of all the inflows of the particular time or particular year. Okay, so a mass inflow curve is looks like this. It's a curve which is having some peak points. So, and one more thing you need to note here is that the mass inflow curve is usually prepared from hydrograph of the river. Okay, hydrograph we already discussed in module 2, and from the hydrograph of the dam for a large number of years, from that data only we are preparing mass inflow curve. Coming to the calculation or method of finding the procedure to finding the capacity of the reservoir from mass inflow curves, this is a procedure. So if we follow these steps, we can easily find out the capacity of the reservoir. So first step is to preparation of the mass inflow curve from flood hydrograph. Okay, from the flood hydrograph we are preparing a mass inflow curve. That is depicted here. This is a mass inflow curve like this. And after drawing mass inflow curve, we need to draw and one more curve, that is demand curve. So demand curve is looked like this, which having a slope. Okay, so this demand curve is particularly for 1 year. After while drawing demand curve, it is very important to note that the scale of mass inflow curve must follows for demand curve as well. Okay, if 1:100 is the scale for mass inflow curve, then demand curve is also will be the same scale only. Okay, that is important. After drawing these two curves, we need to mark apex points in this mass inflow curve. Apex points, as you know, that is the maximum value or peak points in mass inflow curve. Here we can see this is one of the apex point, then A1, A2 is an apex point, and A3 is an apex point. So here there is 3 apex points. And next step, once you mark apex point, then we need to draw a tangent through this apex point. So one more condition is there. While drawing this tangent, it must be parallel to the slope of the demand curve. If this is the slope of the demand curve, then this tangent must be parallel to the slope of the demand curve. Similarly, in the peak point A2, we are drawing a tangent which must be parallel to this demand curve, and similarly in A3 also this tangent must be parallel to this demand curve. Then next step is to measure this vertical intercept. That is nothing but its vertical intercept is drawn starting from this tangent and to the curve. So in this curve, in this particular tangent, E1 D1 is the vertical intercept, and here it is E2 D2 is the vertical intercept, and in this E3 D3 is the vertical intercept. So some of you have a doubt in this, or whether we can draw a vertical intercept here or at this position or this position. Any position we can draw, right? So what is the reason for choosing the vertical intercept at this particular point only? It's nothing but it's a vertical intercept is chosen in such a point that will gives you maximum value of this vertical distance. Okay, we are just placing scales in different position from this tangent, and this is the position which will gives you the maximum value of this vertical distance. Okay, so such a point is need to taken. Which point will gives you maximum value of vertical intercept, that point must be taken. So in this particular area, E1 D1 is the maximum vertical intercept, and in this particular area E2 D2 is the maximum intercept, and in this position E3 D3 is the maximum vertical intercept. Okay, then after drawing this vertical intercept, the next step is, we suppose E1 D1 is the vertical intercept which will gives you a value of 800, and E2 D2 it will gives 2100, and E3 D3 suppose you can say it's 900. Okay, among this we need to compare these 3 vertical intercept. If there is 4 vertical intercept, we need to compare with 4. If there is 5, then we need to compare with this 5. And here there is only 3 vertical intercept. Among these, we need to select the vertical intercept which is having maximum value. Here it is 2100, that is E2 D2 is the maximum vertical intercept. So that vertical intercept will be the required reservoir capacity. Okay, so here in this particular example, required reservoir capacity is E2 D2, that is 2100 hectare meter. Okay, so it is very simple. So after drawing this vertical intercept, we will directly getting the value of reservoir capacity. Okay, then one more thing to add here is that is consider time between A to C2. Okay, this time period we are considering. So this will be a time period between, say, about 61.5 years to 62.5 years approximately. Okay, so between this time period we have this different vertical intercept E to C2, this value. Okay, E to C2, this will be the demand at that particular time. Okay, and C2 D2, that means this much portion, C2 D2 will be the inflow. Okay, and okay, so demand is this much, that is E2 C2, and inflow is only this much, and we need to have an additional water demand, that is E2 D2, that will be the capacity of the reservoir. Okay, capacity. Okay, so these different vertical intercept will have a different meaning, that is E2 C2 is demand and C2 D2 is the inflow, and E2, T2 is the capacity of the reservoir we need to provide. Okay, so that is what is explained in this example. And also note that vertical distance between successive tangents represents water wasted over the spillway. That is nothing but consider B1 is the maximum capacity of the reservoir. Okay, and after B1 this curve is increasing, mass inflow curve is increasing, and after B1 it's the maximum capacity, and this increasing portion is the water which is spilled off. That means after B1 the water that is coming to the reservoir is need to be spilled off, or we need to discharge through the spillway gate. We already studied the function of spillway gate. What is the purpose of spillway gate? That is to remove or to discharge the excess amount of water, that is overflow water from the reservoir. So after B1 this water is spilled off, that is we will open the spillway gate and this excess amount will be overflow. Okay, so I will brief, this is all about the calculation of reservoir capacity. I will brief it, it in a simple way, very simple. That is, first step is to draw the mass inflow curve from flood hydrograph, and then next stage is to prepare a demand curve which is of same scale, and next step is to finding the apex points in mass inflow curve, and next step is to draw a tangent through each of these peak points which must be parallel to the demand curve. The next step is to finding the maximum vertical intercept from each of these tangents, and the last step, that is select the one of the vertical intercept which gives maximum value, which will be the reservoir capacity. Okay, so thank you for watching this video. If you have any queries or doubts regarding this topic, you can ask in comment box. Okay, once again, thank you.